All right. Well, here we got to go back to this now. Okay. And apparently it has this new touchpad thing where it's actually pressure sensitive. So there's like various degrees of how hard you can click and stuff happens, I guess. I don't know. Retina re-envisioned. Your laptop actually says ouch. Trackpad pushed even, oh, I thought it said push even further. Like, I've never really thought about that. I couldn't push far enough. With force touch. Is that phrasing?
Going for that Star Wars.
That was
Star Wars sponsors.
This moves too. That bounces.
It bounces on the ground.
Oh yeah, now there's this new plug.
USB-C.
Yeah, and I think you just plug everything into one port.
Yep. Yeah, supposedly it's got HDMI, everything in that one.
Yeah, so yeah, you probably just get a single dongle, and it's only made by Apple for $4,000, gold plated. Yeah, so this is the whole computer. That's the actual computer. Wasn't there batteries on there before?
Yeah,
Hold on. I got to scroll up in order to. Huh? No, but they were there.
No, yeah,
They were up here.
Batteries in the.
Hold on. We got to reset the battery view. Hold on.
Refresh the page.
Can complain to their designers. Though, wait a minute. Wait. Oh.
You didn't replace the battery.
Yeah, see?
They're going to go away.
That's it?
See, maybe that's just it. Like, that's what the computer looks like on the inside. The battery's on that little chip, too. The whole thing's just empty.
No, because if you look at the top of the batteries actually fill in these little pockets and stuff. Look at that. Up to 9 hours of battery life. This looks like you could like piece this apart and build a weapon. Like some kind of like fan of knives or something. Oh, that moves too. Okay, so we have like all this new stuff, and then just down here they're just talking about OS X. What, at the bottom is like on-off button. So this is what you're saying is a comparison thing? Oh, you can already get MacBooks in different colors too?
That's what it is.
Yeah, that's the new one.
Oh.
They're just calling it a MacBook.
I see. Yeah, I gotcha. I missed that. So it's not a replacement for the Air, it's just a MacBook that is an Air.
They're coming out with a new Air, too, which is pointless.
Well, but isn't this...
Yeah.
Well, hold on. They're coming out with a new Air. But they didn't announce it today.
Like, I think they're coming out with, like, an upgraded Air.
Well, this one is the Air, though.
Yep, but it's not, though. Because it doesn't have the Air after the word MacBook.
Well, right. So I'm guessing they're not going to do Airs anymore.
That's what I'm thinking as well.
Well, it's the super light one. It's 2 pounds. So what are they going to have? The MacBook Air that's actually made of air? You cannot see it.
What's worse about it?
Okay, so like here, this is a new architecture processor.
Yeah.
So the Core M, you can't compare to these.
At least by blind.
Yeah, you can't just look at the gigahertz because this is a different class processor. Battery life, this is 12-inch. This is 13.3. Oh, so this one's just
don't have Retina.
yeah. This one's only a 12-inch screen, so it's actually a new size screen. So this is smaller. This is between the 11 and the 13. Okay, so it has Well, actually, this is 11.6 and this is 13.3. So Apple doesn't get. They're so detailed with their images, but they can't give you all the specs here.
So, what do we know about their new Core M processor? Besides
I don't.
Per hour.
Yeah, 5 watts per hour of power life.
Yeah, like that's efficient.
Yeah. Yeah, see, this is lighter than the either of the old MacBook Airs. 2 pounds. The old ones were 2.5 to 3 pounds. So I'm guessing they're getting away with no more Airs.
Yeah, there's no way they would make Airs after making that.
Guy severs his fingers because the new Air is like sharpened to such an edge. Hey,
Make sure not to turn it sideways because you can't see it.
you might lose it. Especially our new crisp, clear Air color. All right.
See through except when you turn it on.
Transparent. Let's see here. Yeah, but in any case, I was, I think, pretty disappointed in Apple's announcement. I thought the price, there's too many options, and the price just seems to be ridiculous for what it does. Like, I don't even know if I can mention one feature that the watch did that really would help anything. I mean, I can pull my phone out and set reminders. I can get my text messages and stuff. Is it really going to make a difference that it's here on my wrist? And then you have the thing that looked like Apple Pay did not require a thumbprint. So now somebody can steal your watch and go buy stuff? Seemed like that was the case.
That would be bad.
The way they demonstrated Apple Pay today. I mean, there was no thumbprint. I mean, that was the whole thing with this. If you steal my phone, you can't buy crap with Apple Pay on my phone because you don't have my thumbprint. So you have to steal my phone and my thumb.
Except that your fingerprints are probably all over your phone.
Well, yeah, that's true. Actually, I think somebody tried to do something with that, and it didn't. It actually didn't work. Something with how the quartz thing is. Ooh, iOS 8.2 update.
Oh yeah, that came out today too. What do you think of the research kit stuff?
Well, what I actually thought would be cool with Research Kit is, I mean, they have this thing where, actually I was looking at it for tremors. They have a thing for Parkinson's disease, and who knows, maybe that's what I got with my tremors. Age is right.
You don't have the tumor, so.
Yeah, so it's got to be something. So in any case, you can now, with Research Kit, you can download the app, and you hold your phone, and you're giving them feedback based on hand tremors and things like that. But wouldn't it be cool if they did like a two-way Apple Pay type thing where you could actually sell your data to them? Why shouldn't you get paid to let them measure your body stuff? Heart rate, and you can have the, I don't know, eye bucket for measuring fluids. It's USB-C compatible. I don't know how far we need to take this, but eye bucket. Hey. All right. Well, I'm updating my phone, so we'll see.
Yeah,
Yes, I would have bought that. At the $600 price point, if they want to replace one of my eyes with the Apple Eye. Yeah, the Apple Eye. Can't be the II.
Yeah.
It's got to be the Apple Eye. That's their new naming convention. I'd be okay with that. Okay, so let's see where we left off last time. If I remember, we were supposed to have kind of a global server, and it wasn't functioning correctly, right? So we have our server socket listening on port 1, 2, 3, 4. I'm only looping through,
Oh yeah, you're only doing it twice.
trying to get 2 people to chat, right?
Yeah.
Well, no, I thought we had that working.
I think you just tested at the end.
Yeah,
Maybe
we had
now
we had
you
some
use
weird thing where like
people were talking. I wasn't getting anything, but people were seeing what I was typing apparently.
Okay, well, let's walk through this. So,
That's right, you're killing goats.
we're going to say we're waiting, accept the incoming connection, create our connected client object. So a connected client object is this guy. It's going to keep track of the socket as well as an input-output abilities. We'll set those things up in the constructor. And then we have the ability to send a message and receive a message. So that's what a connected client is. So inside of our driver, we create our connected client. We add the clients to our global link list as part of driver. Then we have our response thread, and we spawn that off with a connected client as part of the response thread. This guy comes in. We set the client equal to that, and then we set all clients equal to that, so we have a way of broadcasting. Then down here in run, for each of those connected clients, we say while true, we read in the message, and then we broadcast it to all clients. Right? All right, well, so this looks like it should do what it's supposed to do. So I'll run this. And then option. All right, so we need some people to connect. Well, we need two people to connect. So you two? 172, 31, 230, 9. Port 1234. Okay, we got one connected. Got two connected. So you guys should be able to talk to each other now. One has to go before the other. It's like it's send a message, then receive a message. Is it going back and forth?
Well, I'm not. Someone beat me to it.
Who connected?
Someone sending multiple messages.
Oh. Are you receiving? And you're sending? You receiving?
Yes.
So what wasn't working last class?
More than two?
Well, I haven't changed the code, though. Did we change it right at the end of class?
I don't think so.
Pretty sure it was working.
Huh? Oh, it was working? For some reason, I thought it wasn't working. Yeah, you should be able to type as much as you want now. We were trying to make a chat server. So now I should be able to go into driver and just say while true. And this should work for, so you guys both just got disconnected, I think.
No.
Yeah, I think you will be.
Oh, yeah.
All right. Now everybody can connect. We should be able to handle more than two people now. So 172, 31, 230, 9. To get two people connected. 3. 4. And everybody should be typing and see what shows up. I would connect myself, but I'm a little concerned with what might be recorded on my screen based on broadcast messages from the class. Is it working? Everybody sending messages to everybody, and we're seeing everybody's messages. So I want to know.
Someone's claiming to be the Amish god.
Is that Tim?
I think it is.
What do you mean, probably? You're not sure if you're the only one? Okay. So in any case, that's a working chat server.
Amish God demands bacon.
Actually, funny quote at lunch today. One of my other students, they had bacon cheeseburgers in the cafeteria today, and he dropped his bacon off at my. He put his bacon on my plate,
Go and have lunch.
and oh, it's your cousin.
Yep.
Yeah, he goes. This is one of the perks of having a Muslim friend, is you get his bacon. I suppose there are. I suppose it's true. Free bacon. So, in any case, that's our server. So now what we want to do is we want to start turning the corner a little bit and moving towards having a situation where we can have a list of files that we are serving. Okay? So we need to have a list of files that we're serving. So when each person connects, they are connecting as a client of this guy. Now, right off the bat, we're going to have to write our own client application. So you think about this in terms of BitTorrent or Napster or any of those guys, any of the peer-to-peer networks that you've used. You never could do them through a built-in tool. You always had to download the Napster client or the BitTorrent client, something like that, right? You needed a piece of software that knew how to talk to it. So at this point, we're going to have to build our own client application for talking, because right now we are using Terminal to use Telnet to talk directly to a socket, because we're generically talking to the socket, just sending text. But what we need to do is we need to be able to have it respond with a list. That makes sense? Where you connect and you're either making files available, you're serving files, or you're downloading files. That makes sense? So now what we need to do is we need to take this exact same model and then go and modify our network client to work with it. So if we open up our network client, okay, we're going to put on the 172.31.239. And this is port 1234. Okay. So this will open up a socket connection there. Then we're creating our way to read from that, our way to write to it. But we need to create some additional objects, I think, for handling this. But initially, we're just going to test this for a few minutes because I do want to talk about the midterm. So, socket, scanner, get our input. Then we can write something out to our screen, whatever we read in. And then here's our output, and then we can write something out. Say blah, and this guy, we'll say true, so it auto flushes. So actually, let's say blah concatenated with S. So that'll show us that it came from two different socket connections. Okay, so that's our current little client. I'll go ahead and get our server started over here, which is going to listen on server socket 1, 2, 3, 4. And I suppose you guys can connect if you really want to. And now I'm going to go into the client, and I need to get the show in System Explorer. Something crashed. Is it working still?
No.
Oh, it crashed?
No.
Like crashed? I still see people connecting. Is it still working?
Yeah, it's working.
All right, so I'm going to do javac driver.java. So I'm going to connect now with my driver program. So it should say my socket address blah to everybody. So you tell me if you see that.
Yeah.
Yes.
Okay, and then now you guys type something, and I should see it. Kill me. This is recorded. All right. So now we have a client application and a terminal application. I mean, I'm running a Java program. Work. All right. So in any case, what we're going to want to do as we move on here is we're going to want to have some sort of protocol that we're going to be speaking between our client and our server. Because the server is going to keep track of the files that are being served and the files that want to be downloaded. Okay, so for instance, if I connect in and I want to share a Word document, I'm going to have to, through my client application, let them know that there's a Word document in this directory that I want to share. And then that will register with the server, so the server can then show a list of files that are currently available. So that anybody who logs in can type in a command, see a list of files that are currently available, and start downloading them. Okay? In order for us to do that, we're going to have to initially create a hard-coded example of moving a file, a binary file, from one point to the other point, okay, without any requests. So we'll have to look at how do we stream bits across the network connection. Make sense? Okay. So let's now talk about our midterm, which will be on Wednesday. And I will have them back to you by Friday before we're on break. So you know how bad it is. Okay, so it's going to be over everything we've covered as well as things that we've not covered in class. So let's talk about some of these things.
Based on the average income of America, how many people will buy the 17K Apple Watch?
He did say it was going to be limited supplies of that one,
So,
and only available at certain retailers.
so one available at the headquarters.
No, I'm sure New York stores and probably downtown Chicago will. Okay, so kind of talking about the internet as a whole. What things make up the internet? So the idea of what's a host. The different communication mediums, fiber, copper, radio. Talking about transmission rates, the difference between bandwidth and like ping, what we did with trace routes. So what does it mean to have a maximum speed per second versus how long does it take us to propagate from point 1 to point 2? At a high level, what's the idea of packet switching? So being able to divide our data up into small packets and send them across the internet. And why is that beneficial? Of course, you'll need to be able to know all the serial numbers of all the internet-enabled toasters.
All of them?
All of them. All of them.
China blocks their IP addresses.
No, not serial numbers. Serial numbers of all the individual models. Actually, wouldn't every iPod have its own serial number?
Mm-hmm.
Yes, you need to know all the serial numbers of every internet-aware toaster. It's a thing. Okay, kind of the definition of the internet. If I were to ask you to explain to me what the internet is, prove to me you understand what the internet is. Concept of protocols, why we need them. Maybe the difference between the internet as a general entity and some of the services it provides, like web and email and those types of things. Is that the internet, or is that a service of the internet, and what's the difference? Now, realistically, I will probably ask questions that are more generalistic in nature. So I might give you a scenario and tell you to is this an example of A or is this an example of B and why? Something like that. So I want you to show me that you understand what these concepts mean, not that you just memorized a bunch of words. Okay, so kind of our whole section on protocols, what they're for, negotiating back and forth. The idea of routers sitting at the edge of a network. So we talked about the edge router here on campus and what its job was and how those guys also act as firewalls. So along those lines, what's the nature of a firewall? Difference between wired and wireless communication links. I will certainly ask some questions dealing with converting, megabits per second to kilobytes per second, that kind of stuff. So be able to go from a certain speed to another speed. If I give you a bandwidth and I ask you, as an example, if I say you have let's say I say you have a 30 megabit per second internet connection. What's the maximum amount of data you can download in 5 minutes? Something like that. 30 megabit per second is how much you can get in 1 second. So now you need to propagate that over, what did I say, 4 minutes? Okay, 5 minutes. 5 times 60 seconds in a minute. And times 30 megabits per second, and then put it into a format that would be easy. I suppose you can answer the question in terms of how many bits you can download. But I might say, how many megabytes can you get in 5 minutes with a 30 megabit per second internet connection? Questions kind of like that. So show me that you can apply these things in some interesting way. Difference between shared and dedicated bandwidth, kind of our discussion between DSL and cable, and some of the early problems with cable modems, dealing with two-way communication. So early problems with DSL, final mile type stuff, which is better, DSL or cable, and why? So kind of make an argument where DSL has that, there isn't necessarily a right answer, but there are plenty wrong ones. DSL being a dedicated circuit as opposed to cable being a shared bandwidth situation, which is better and why, and then starting to get into some of these conversations where even if DSL is dedicated, who knows whether they've gone through like the hotel model where they've oversold their bandwidth. Okay, so show me that you understand the things that go into DSL and cable in terms of decision making. If I ask you a question like which is better and why, I don't know if I'll ask that or not, but I don't necessarily care which one you pick as the winner. I want to know your reasons. Is this a valid reason? DSL works this way, cable works this way, and this is why I think this is preferred for me, or something like that. Show me you understand the technologies. Asynchronous versus synchronous internet connections. So asynchronous being downloads faster than upload, typically, where one of the streams is a different speed and then the other stream would be actually asynchronous, but typically it's the download is a lot faster than the upload. Okay, how does our cable network work? Specifically the early cable modems that could not send requests out, so you had to use dial-up modems. talking about when we were talking about HDTV, we were really doing this in terms of data transmitted. So if we're watching a television signal and we're trying to watch 1080p, which is 1920 by 1080 pixels, and each of those pixels, so if I were to give you a question that said something like, assume you're watching a 60-minute TV show broadcast at 1080p, where each pixel is represented in 32-bit color. So that means every pixel would be a 32-bit number. Okay? And you have 1920 by times 1080 number of pixels times 32 bits. And you get 24 frames per second. So 24 of those times that number of bits every second. And it's 60 minutes long. How much total bandwidth is going to be coming across? How much do you have to download? So be able to do math, converting between seconds and number of bits in color and stuff like that. Something we want to be comfortable with as computer scientists is not being intimidated with the idea of bits and bytes and kilobytes and pixels and things like that. Things that seem maybe unnerving on the surface really don't mean that much. So I would give you all the given information. You would have to just plug and chug it. Make sense? Let's see. Certainly how NATs work, network address translation, kind of our local, the routers, wireless routers or wired routers we get at our house where they hand out their own IP addresses and the internal machines get a non-routable IP address and how they're able to make requests through what would be their edge router. Similarly, kind of an enterprise type setup versus a home setup. Here we have a setup where we have an edge router. Then we have 2 switches which create local area networks. So understand what kind of scenarios these can create where if I have these machines here and I want to share data with these machines here, how that might work. If I were to ask, can this machine get to this machine or something like that. All right, in terms of wireless stuff, not just Wi-Fi, we also talked about some of the technologies dealing with cell. So, 3G versus 4G versus LTE and how those technologies compare, GSM versus CDMA. So I potentially would ask questions about that stuff. Already kind of mentioned that with packets. Already kind of mentioned this physical stuff. It took me about 15 seconds to figure out what that was.
I remember when I had trouble before. Didn't you think there was a slug or something?
Yeah.
Snail
or worse. I don't know what worse, but just worse. All right, so, are different types of communication mediums. Concept of store and forward, why do we need it? Maybe given a picture of a network, point out the places where there can be delays and explain why. I would probably say this is a router, this is a router, this is a router, and you would have to kind of understand that TCP/IP stack as we're coming up at. We talked about core switching a little bit, but I wouldn't probably ask any questions about it. Frequency division versus time division multiplexing. Pros and cons. Again, I probably wouldn't ask any questions about circuit switched networks. We got to DNS stuff yet? Okay, so this is kind of starting to talk about DNS, domain name service, and how we pass the buck up to the higher tiers and that kind of stuff. So I could ask a question about how does DNS work, or give you a specific scenario and what will this resolve to, something like that.
Bonus question on who is the head of the human centipede?
The individual from class?
That's probably extra credit, right?
Maybe.
What do you do if there's a horde of human centipedes?
Are they centipeded together?
It's like multiple.
It's like, oh yeah, oh yeah. Okay. Let's see. So here's our sources of packet delay: transmission, nodal processing, queuing, and propagation. These are places where things can slow down. Purpose of traceroute, kind of understanding what that program's for. The idea of packet loss and how do we recover from it. That kind of relates to stored forward and also TCP/IP. Okay, then we start getting to the different layers for Internet Protocol stack: application, transport, network, link, and physical. What does each layer do? So TCP/IP is a 5-layer. OSI is a 7-layer. They're the same things. They just break it up to a couple different layers. I probably would not ask you anything about OSI. I would probably, so if you're going to go in and kind of memorize IP stack stuff, know these 5 and how they work and compare and contrast type stuff. I wouldn't worry about the OSI. Let's see, network attack stuff. Certainly, we talked about some denial of service stuff, and then DDoS, distributed denial of service, how that works. Packet sniffing. Okay, I'd say that's it. Questions? So it would be like, designed to take 30 or 40 minutes, closed book, all short answer essay, no multiple choice or anything like that. I won't have you write any programs, but I might have a program on there and ask you to tell me what it does. That would be fair game. So maybe I show you a server type thing and tell you how this works, ask you to explain to me what it's doing or something like that. We good? So this will be on Wednesday. As soon as you're done, you can take off. I will hand them back on Friday before break, so you know the bad news. And I will see everybody then.
Make sure we have the bad news before